Good morning. Welcome to another episode of Ksar Talk Show. Today we are going to code Advent of Code 2024, Day 4 with Wolfram language, Fantastic Wolf Girl, generated by Grok. So let's begin coding Wolfram language. Okay. And if you don't know already, you just search my website, xadi.info. You'll find my talk show pages, lots of talk show. So now it's episode 600. And there's Advent of Code 2024 index. So you can find past solutions in Wolfram language. They are the shortest solution on earth. Okay, because Wolfram language is the most high-level language by a magnitude than them all, than Lisp, Clojure, Haskell, or Camel, F#, of course, a lot more higher level than Python, JavaScript, Ruby, or C++ and Java. Those are low level. So anyway, so Wolfram language, Advent of Code. Yeah, okay, let's begin, shall we? If you are here, say hi. If you are not here, play at 1.5 speed because I ramble a lot. 1.5 speed minimum and skip around, okay? So video check, audio check. Am I good to go? Yes. Am my live quality good? Okay, so number 4, Advent of Code, number 4. Yeah, okay, let's see. Let's begin. Okay, so looks like the chef's not here. Next, something as the search for the chief continues. A small elf something. This word search allows words to be horizontal. Okay, so wait. As the search for the chief continues, a small elf who lives on the station tugs on your shirt. She'd like to know. Oh, it's a she. Lovely. She elf. She'd like to know if you could help her with her word search. Oh, yeah, of course. If it's a she, yes, I'm gonna help you. Help her with her word search, your puzzle input. Okay, she only has to find one word, Xmas, Christmas. This word search allows words to be horizontal, vertical, diagonal, written backwards, or even overlapping other words, okay? Horizontal, vertical, diagonal, and also backwards, including diagonal, I suppose, and vertical, or even overlapping other words. It's a little unusual, though, as you don't merely need to find one instance of Xmas. You need to find all of them. All of them. Here are a few ways Xmas might appear where irrelevant characters have been replaced with dot. Okay, so let's see. Okay, so you see this. So can you see? Yeah. So you got XMAX. Okay, so this reversed XMAS. Wait, so here is a vertical one, XMAX, reverse vertical, reverse right to left, and the bottom to top, and here is left to right, and here is upper left to lower right, diagonal, and Xmas. Okay, so did we check them? Did we find them all Xmas? So starting with X, so you can start to look by just X. X is the starting position. So how many we have? 1, 2, 3. We only got 3. The actual word search will be full of letters instead. Okay, so in this word search, Xmas occurred a total of 18 times. Okay, here's the same word search again, but where letters not involved in any Xmas have been replaced with dot. Okay, So there are 18 occurrences in this block of text. Okay, so Xmas up to top, down, bottom to top, Xmas lower right to upper left, Xmas lower left to upper right. Okay, I think I got the idea. So can there be a gap? Let's see. Can there be a gap? Take a look at the little elf's word search. How many times does Xmas appear? Okay, so in this, okay, let's begin coding. So this is a block of code. Copy it. Show in browser. Okay, so let's begin. Wolfram language. This is Wolfram language in XAR Wolfram mod. You can find it on GitHub. It's free. It allows you to code Wolfram language in Emacs so that you can have efficient, for example, I run it. First time takes a while, so you see this is the output. This is just a string, okay? So, and we can do it in Wolfram language notepad. I already started. There it is. Okay, so you want to find, so we need to start to think about algorithm, like what is the instruction, how do you solve this? Anyone here yet? Hello Dave. Okay, have you coded Wolfram language before? What language do you code? So okay, so we got this. Let's see. So the first question is, can you have a gap between words? It didn't say. Did it say? You don't merely need to, you need to find all of them, okay? All the examples here, in this example, there are 3 occurrences, I believe. However, they didn't say. So let's double check. Bottom to top, right to left, that's 2. Then left to right, that's 3. Then top left to lower right, 4. See, 1, 2, okay, 1, 2, 3, 4. So high. So there are 4 occurrences in this example. 4. Let's see, 1, 2, 3, 4. Now, you see, we want to check if there's a gap. If there's a gap, does it count? You see, in this example, it doesn't show such occurrence, so it's ambivalent. We cannot tell from this example. XMAS, okay, I presume a gap does not count. Yeah, because otherwise then you could have XXMMAASS, and that would count as 2 because you skip a letter each time. So I would presume the gap, you cannot have gaps. Gaps are not allowed, okay? Okay, so you got this 18 times. So, okay, let's think about the algorithm. How do you do this then? Okay, this is a tedious problem. There's no apparent way to solve it. You see, there's no problem with horizontal or vertical, because horizontal you can easily check, and for reverse horizontal, all you have to do is just reverse each row. Trivial. For vertical, all you have to do is you transpose, you turn this into a matrix and transpose, which means flip it on a vertical, on a diagonal axis, transposition of the matrix. Then you can just check horizontally like before. So vertical and horizontal, there's no problem, trivial. The problem is with diagonal. So is there so we have to think about a way, an easy way to find a diagonal. Of course, you can like do the brainless brute force by increment of the index horizontal decrease by 1 and row increase by 1. So that's very tedious. So the horizontal, okay, so you need a way. Is there a way to turn the diagonals into just rows? So that then you become trivial. So you need the backslash diagonal, and you need the reverse backslash. The slash in versus backslash. Okay, so can you turn a matrix and extract the diagonal? That's the question. Yes. Let me write down the algorithm. So because when algorithm, when we do a long live video, when you have something write down, people can see right away. For horizontal, did I spell it correctly? No. Horizontal. It's trivial. Reverse row, trivial. For vertical, just transpose the matrix. For diagonal, you need to turn the diagonals into rows. Can that be done? I believe so. In Wolfram language, you have, so although I don't know what is, so all you have to do, just search for diagonal, okay, question mark, asterisk, diagonal. It can, I believe there's a function that gives you the diagonal matrix. What? Okay, Control L, capital D. Okay, there it is. Block diagonal matrix, diagonalizable matrix Q. Diagonal matrix. Okay, so you got several. Let's look at one of them. Represent the. So once you have this function built in, it's trivial. You see. Without this function, it's tedious. The index, like the C idiots, C and C++ and Java and C#. This C virus induced idiocy. Okay, so let's represent the block diagonal matrix with diagonal blocks D as a structural way. Okay, you actually keep the list of elements on the leading diagonal of the matrix. Okay, leading diagonal. Okay, diagonal matrix. Okay, gives the matrix with the elements of list on the leading diagonal. Okay, so so diagonal matrix is a mathematical concept in math. They so let's see. So probably this is the one we want to use. Let's see. Yeah. Okay, but then you need a k, give the elements on the kth diagonal. So if the matrix you have, let's see, how do they count? Is a k by row or okay, let's try this. copy that. Let's just play it, okay? So you got that. Then let's assign it. XX equals to, we shift enter, assign it. So now we, I believe diagonal. Yeah. So diagonal and XX, then let's say 1. What do you get? Shift enter. BF. Okay, so let's try again. Let's see 0. Shift enter. So 0 is AEI. Okay, 1 is BF. Now if you say 2, that's gonna be just C. Okay, fantastic. Now let's see. So it goes by the number of columns starting with 0. Okay, so 0 is the main diagonal. Okay, so you need to think about so if you say -1, that's gonna give you DH. Shift enter. That's right. So in the negative direction, you will have the number of rows. So if you have 3 rows, then you have 0, -1, and -2. Okay, so -2 is gonna be just G. Okay, we got the, now we understand this diagonal function. Now, is it possible just actually just give you all the diagonals? Okay. Let's try. What is this diagonal matrix? Oh, okay, it just generates a matrix with certain diagonals. Okay, that's not what we want. Okay, but this diagonal is what we want. Okay. So once you have this, it becomes trivial. What about reverse diagonal? Let's see. Then you just transpose, right? You just transpose it, then you got the reverse diagonal. Okay. So let's, okay, we almost done. So we got the diagonal. From diagonal means top left to bottom right. Okay, once you get it, you check it, then you reverse each row, then you got lower right to top left. Okay, then so you checked all the diagonals from the backslash, then you transpose the matrix, then you do the diagonal again. That's gonna be, and you also reverse. So yeah, okay, then that's yes, via the Wolfram language function. Okay. diagonal, diagonal. Okay, that's the algorithm. Let's do it then. So that's the input. Let's so that's the normal way. You want to check each row. Okay, so check each row. So for each row, what you do is you want to first of all, you need to turn this into a matrix. Okay, let me show you how to do that. Okay, well, first of all, x input equals to, first of all, we turn it into a matrix. So string split. String split, by default it'll split by white space. Okay, so X input. So you got that. Then you want to map the characters represent a single character in read. No, characters. Okay, characters will turn a string into each characters, return a list. Okay, yeah. So you want map characters, the function, to that. Okay, then you got matrix. Okay, which let's run it. Yeah, so you can see, if we you see we got a matrix. You see, cut. Beautiful. So wait, you don't want to because now you want to do regular expression on each one. You don't want the okay, but if you don't turn it into a matrix, then it's hard to do transposition. So you have to turn it into a matrix. Then for each row you put them back into a string. Okay. That's doable. So now the task is, how do you have a list of strings, turn them back into a string. Okay, that's let's see, string join. Let's magnify this so it's easier to read. Okay, all you have to do is just use string join. So let's show you string join. Okay, for example, you have the list AA and BB and CC, and eval this line. There it is, you got a string. So that's good. So what we have to do now is just hold on a second. Okay, so what we have to do now is, you got the matrix, then you want to what do you want to do with the matrix? Map. Okay, so yeah, so map and string join, then you got a string. Okay, so list of string rows. Okay, that's what it is. Okay, run it. Yeah, that's what you want. So now you just do a regular expression. Just check if so you just do a regular expression. You check. So first of all, remember this is a canonical form. So every time you got, we begin with this bunch of thing, we turn it into this, then we can do the check. We can find all the xmas. Okay, yeah. So now regular expression. Okay, regular expression. string cases, I believe. By the way, overlap also count, remember? Okay. String cases, let's see an example. Let's just say Xmas. Is it possible to overlap with that word? No. Xmas, no. So Xmas is just Xmas. If you only check for left to right, it's not possible to overlap. That will occur only if your word contains, let's say, the word has repeated letters, let's say XMA, then it's possible to overlap. So, okay. So string cases take a string, let's say Xmas twice, and then you use a regular expression, in this case Xmas. Okay, evaluate the line. Right, so it give you 2 count, then you just say count. Just say length, okay? Actually, string can you count directly? Yep, you can count directly without, get the cases first. Yes, okay? So you can actually count directly. Let's put this there so people understand. That just returned 2. Fantastic. Okay. So this is 1 row. So, but now you have you just need to do these 2 old rows. So you map a function to this list of rows, and you do string count. Okay, map the function to that, then you just total it. Okay, and what we got? Yeah, so can we evaluate the whole thing? Yes. So that will give you, okay, something is wrong. Oh, it requires 2 args. Yeah, that's right. So you write a function, string count, and here's a string, and you want to count Xmas. Evaluate. 0. 0 is not what we want. Let's see. Evaluate all output. String count. So why is it? Let's see what is the output. List of rows. Okay, so did we what? List of string rows. What is the value of that? Yeah, it why is it 0? Okay, I don't know. Okay. Search for Xmas. So there is 3 occurrences at least. Okay. So actually, let's highlight all the words Xmas. Okay, so that fantastic editor feature. Hello guys, so hello guys, say hi. So it occurred that many times. So why is our function not working? Because of the capitalization, I assume. Yeah, let's try that. Fantastic capitalization issue. Yeah, okay, so so let's just capitalize them all. In fact, let's just find and replace so that we is okay, right? Then just total, okay? So this is left to right. There are a total of 3 occurrences, okay? Then you want to reverse, okay? So reverse the rows. So you want to map it again, but you need to reverse the string. Reverse, actually string reverse. There it is. Okay, so now you get reverse 2. Okay, so let's say 3 here, then 2 here. Okay, so let's see. So what is reverse is SAMX. Okay, let's try to highlight it. SAMX, SAMX, pink. Okay, 2 occurrences. Yes, nice highlighting. Okay, so that is all the horizontal, a total of 5. Okay, now we need to clean up the function so then we can apply to the the other directions. Okay, now clean up the function. So okay, so yeah, so let's clean up the function. So let's write the function. Let's say horizontal. Did I spell that right? Horizontal. Stupid English. Okay, we're gonna write this function equals to a function, and this function will be, so the function takes a matrix. The x is a matrix. Let's say matrix. Okay, and what will the body do? The body will be something like that. In fact, more. Let's see. So total of that and total of that and list of string rows. So that's the canonical form we want to feed to our function. So let's not say matrix. So this is the list of string forms is our function parameter. Okay, so that just plus that. Okay, you just plus them. That will count in one direction and reverse. Okay, so that is our function. And can we try it? Yes. So let's just try add x list of rows. So that should work. Now let's double check where does this definition. Okay, so let's remove list of string rows. It's defined there. Yeah, so you don't need that, and in fact move this here so it's easy to see. Right now this is a scratch pad showing how it works. Okay, so we got this is a matrix, then this is string join. We don't need string join. Yeah, okay, we don't need. So this is a list of string rows which comes in this form. Then we can do string cases and string count, and we use string count to so we don't need that. So now we can try list of string rows. Let's double check. Yeah, it's there. Yes. Okay, but it should be 5, correct. Okay, so this is our function. Now let's check. So horizontal equals to this result, vertical equals to let's say total. Okay, let's just say clarity. We are doing clarity here. Okay, so you need vertical, you need transpose. Okay, so let's see. So we're gonna do actually not this. Okay, so the horizontal, let's do this manually. Okay, so the horizontal will be the input will be the matrix. Yeah, there. So you give a matrix, then you that's the, then you join the strings, then it's just a list of strings. Okay, it's total. Then vertical total is gonna be the vertical total is gonna be same thing, kind of the same thing, except you're gonna transpose the matrix. Okay, run it. 3, fantastic. Shall we check? Let's not. So what about diagonal? Now the diagonal horizontal, vertical, there are 2 diagonals, so you need a term to distinguish. So can we say slash and backslash? Slash. Slash and backslash. Actually, so the backslash direction is properly called diagonal in math. Okay. Now what about the other diagonal? What's the proper term for that? I don't know. Is there a proper term for that? Maybe, but I don't know. So, but anyway, diagonal means left top left to bottom right in math. Okay, so diagonal total will be you use the diagonal function. We have the documentation here. Diagonal matrix. Okay, this needs some work. So diagonal matrix takes two arguments. The first one is a matrix. Then you need to get all the diagonals. So let's see, we understand before. So first of all, you need to know the size of the matrix, dimensions, okay? Dimensions of the matrix, which is the row count, then the column count. Row and column. So let's see, let me just think about this. So row minus 1. Okay, so actually let me just do it. Range row count minus 1 to the column count minus 1. Okay, I like to name my variables beginning with x. Okay, so and the row count and the dimensions of the matrix. Okay, that gives you row and column. Okay, let's see. Okay, it's so that's the dimension. Then first, okay, second, okay, and what will this give you is, for example, if it's 3 by 3 matrix, it will give you -2, -1, 0, 1, 2. Let's run it. Okay, you need to define the matrix. Okay, run the whole thing. Okay, we got some syntax wrong. Comment that out. We don't know what is this yet. Okay, so let's just do that. What? Comma encountered. Where the fuck comma encountered? Oh yeah, this extra comma. Wait, we got it wrong. What? What? This is wrong. Yeah, this is entirely fucked up. And we have to rewrite this again, I'm afraid. So there is our dimension. Then you just do this dimension first. Okay, minus 1, okay? Then dimension second part minus 1, then range, okay, range of these two numbers, okay? Yeah, so run it. Nine. No, 9 is not correct. What is going on? Yeah, let's use variables, okay? Variables make everything clear. Fuck, it's taking a while. This is row count, column count, then this range is just be, now it's simpler. Remember, you need to minus 1, okay? Wait, what 9? Show all results. Oh yeah, you forgot to negative it. The row count 3 minus 1, then you just say negative. You need to negative it. Yeah, so negative is what? Negate. Let's say negative 3. Let's run this line. Let's see if that gives you no. Is there a negate? What is the math term to reverse sign? I forgot. So let's look up the documentation. It will tell you. Negative true gives true if x is a negative number. Okay, so non-positive real sign, simplified real sign. Negation. We want some. We want a negation. Oh yeah, we can just put a minus in front. Wait, and that. Okay, do it again. Beautiful. Now we have a 9 by 9 matrix. Is that right? Beautiful. Okay. So we can see this is the output. Beautiful. Now, so what are we doing? But we are doing the diagonal part. So the diagonal part, let's do it here. Vertical and horizontal is easy. Here's the diagonal part. So diagonal part, we need to get the diagonal matrix, but the diagonal matrix, each time it just take 1. So that's why you need this range thing to get them all. Is there a way, I want them in one shot. Is there a way just to get all the diagonal in one shot? Actually, this is not diagonal matrix. It should be diagonal. Diagonal gives the list of elements on the leading diagonal. Okay, then diagonal matrix and K gives the elements on the kth diagonal. Okay, Works even M is not a square matrix. Yes, if the K is positive, diagonal gives the diagonals above the leading diagonal. That's right. Yeah, but is there a way to just like get all the diagonal like in one shot without? I don't know. Maybe that's too much to ask. Let's just do it manually. Okay, so you want to do it manually, you just put K here and you just say table. Table is like Python's least comprehension, one idiotic Python jargon. You know, these people, Python and others, they think they know math. Oh, least comprehension, which is in fact the most idiotic fuck. Okay, so you use a table. Now you just say K from K is just from that to that. Okay. So K, let's just say KK. So to avoid my abbreviation expansion, yeah, that will do. So actually, can we run it? Yes. So you can see this is how it works. Okay, so give the get the diagonal and K and generate all of them by this range. Run it. Okay, so we got the output. Copy it, and let's see. Fantastic, beautiful. We got a Christmas tree. Oh God, this fantastic. So we need to check. Is our diagonal properly done? So how does it begin? So begin from the bottom. So so you got M, you got MX, then you got Sam, then you got Sam X, that's right. Then all the way, then the leading diagonal is MSXM A MSXMA, that's correct. Then the top one, the top right corner is M again, and SA, correct. Fantastic and beautiful. Okay, so we got all the diagonals. Yeah, all diagonals. Okay, so this is all diagonals. Okay, but okay, yeah, we got that. That's beautiful. And but then you just apply the same algorithm to you see. Okay, so let's abuse variables. Let's just name them all diagonals equals to that. Then you just count them by map. You don't need transpose, you just need do it all diagonals. String join, correct. Then count horizontal, vertical diagonal. Let's see. 5. Is that correct? So let's say X must, there's 5 occurrences. It's hard to see from here, but we could, if we want to, by just running this line. Yeah, let's try. Oh no, but we don't have the variable. Okay, but it says 5. Okay, so it. Yeah, it says 5. Okay. And wait, this is not vertical. Okay, so this is diagonal. Okay. Horizontal, vertical. Okay, so this needs to be renamed. DIAG. Okay, and what about reverse diagonal? It's the same thing, except we just add a transpose function here. We just add a transpose function there. Okay, so there and there. Okay, God, this is tedious. I'm already almost an hour. What the fuck? Blue Owl says, hi, enjoy your content. Hope to see more math videos and live stream. Thank you. I find the different graph showed very fascinating, also tiling. Oh, yeah, those are the most fun topics. Hello, Hank. Happy holidays. Merry Christmas, Hank. So now, so we got the diagonals, but this code needs to be compacted, okay? Because you can see the variables are used several places. So how shall we approach? Yeah, let's compact this code so that it becomes one single function. Okay, so let's begin. So count is a function, okay, equals to a function. Okay, now the function we are taking a matrix, okay, X matrix, okay, then what does it do? It will let's start to move in. So first of all, with a width function, okay, width function is it's a local variable, okay, it's like Lisp's let. Should I use width or let's see. Width, this width is like Lisp's let or JavaScript let. It declares local variables, but both module and width. But however, with width, it's a constant. So once you define it, you cannot change it, which is great for functional programming. However, it's got a problem because once you define a variable, you cannot define the next variable in terms of the previous one, like we need here. We get a dimension, then you get row count based on the dimension. You cannot do that because so what you have to do is you declare another width. So that's not good. So in another way is just use module. Module is just like let, but you can redefine the value. Okay, let's use module. Okay, let's not get to. So cut that, put here. Okay, in fact, put the definition here, and let's just have variables here. Okay, so you got 3 variables, then you define each them individually in a body. You got matrix size, row count, column count, then you got range, okay, X range, you need a range. Okay, the range will be that, okay, semicolon to suppress the output, okay. then then you get all diagonals and then count. Okay, so we don't need this section. Let's copy that. Let's see. Then you just you have to call count horizontal. So all diagonals. Okay, so let's just put it here for clarity of code. Okay, then you call this function. Then it's total. You don't need that. It just return the last expression like Lisp. Okay, so here is our function, and we can try it by add X matrix, because we defined the matrix there. Okay, so go back here a minute. What was the number? 3 or 5? Okay, there are 5. Okay. Then you, if you want to count the other position of diagonal, just say transpose, not translate, transpose. Okay. 5. Is it also 5? Jesus. Yeah, you know, this diagonal is hard to debug because you cannot. You know, so this is our function. Let's like go to Wolfram Notepad, paste it. It make it more clear. You see. Copy it, then you can just paste here somewhat cleaner with indentation. Yeah, okay. But let's double check. Okay, so you got the dimension, you got the row count, dimension, row count, column count, then you get the range of values, then you get all the diagonals by calling a table. Diagonals kk goes from this range. This is repeated, so this just x range. Okay, then so you got all the diagonals, then you just count horizontal, pass the value all diagonals, turn them into string, turn each row into a string, then you count. Yeah. Is that right? Yeah. Does that make sense? Yeah. So if you count diagonals with the matrix, you get, you see, this count horizontal counts both directions. Okay, so you can see the count horizontal counts in both directions. You see, because we did a string reverse there, it counts. Actually, we don't, another trick is, instead of, we just can, instead of reverse the string, we just reverse the xy. Yeah, let's do that. That's actually SAMX. That's actually more efficient. Yeah. SAMX, okay. Yeah, okay, so yeah, so the count horizontal is the core function, okay, and you feed it. Yeah, so horizontal total is count horizontal string join and give it a matrix. Count vertical is you transpose, then string join, then count horizontal. Then wait, then yeah. Then for diagonal, it's what let's see. That should be it. But what about so diagonal total equals to that. What is the word for the other diagonal of the matrix? Transverse diagonal, maybe. Can you, am I still doing good? Check video. Warning, stream health, good. Part 1 or 2? Part 1, man. I'm still stuck on part 1. It's getting more difficult and more difficult. Let's see. Okay, it's called anti-diagonal mathematics. Fantastic. You see, normally top left to bottom right is diagonal, but the other diagonal is called anti-diagonal. Fantastic. So let's name it here. You know, the proper terminology helps you a lot, because when you read the word, you know you get the proper thinking about it. So that's why terminology is of great importance. Okay. So diagonal total is that. Then what is this? Then you want anti-diagonal total. Okay, which is that. Is that right? Because when you transmit, you have to think about it. When you transpose the matrix, so normally you want that. When you transpose, yeah, that's right. Yes, that's right. So it so happens it's also 5. Evaluate it, let's see. It so happens it's also 5, okay? So let's tab, let's show all results. 5 and 5 and what? 5 and I don't know. So I mean, so let's. Okay, so that's our code. Supposedly we give that. Wait. Let's do this. Let's add them together. Okay. So diagonal total plus plus anti-diagonal total plus vertical total and horizontal total. Okay. 18. I think that's right. Check. $18 times. Fantastic. Beautiful. Okay. So this is a scratch pad. We got it done. Fantastic. Now put back in the browser. Syntax code showing browser. This is today's code. This is a scratch pad. Now let's make this beautiful. Let's actually make this beautiful. Okay. So don't worry about algorithm and where is this input used. Okay, so this input, let's clean up. You don't need that. Okay, so you don't need that. List of rows, list of strings. Okay, list of strings. Actually change your name. List of strings. Yeah, you can change name, just list of strings. Okay. So list of strings. Do you need the matrix? Do you need the matrix defined? We are trying to reduce variables here. So to make them all a function, so it becomes 18. Okay, string cases, we don't need string count, we don't need total. What is this total? Total 3. Yeah, we don't need. You don't need horizontal total. Yeah. Count horizontal. This is important function. Okay, this is an important function. And instead of list of strings, we okay, let's not worry about it. So list of strings, then count horizontal. Okay, so that is important function. And do we need this? This is important. List of strings we don't need. No. Okay, so count horizontal is the important function. Remove that. So this horizontal total and wait, horizontal total, vertical total, then we don't need this whole thing. Then count diagonal we need. Okay, so count diagonal. Yeah, so we can, this is a function. Let's put the function here. this is a function. Okay, so count diagonal is a function. We got count horizontal function, count diagonal function. Then you just count them. So you got horizontal, vertical, diagonal, and anti-diagonal. So you got these 4 values. Okay, then you just add them, evaluate it. Beautiful. Okay, so the code is just this. Okay, now you want to try your personal input. So let's see, get your personal input. Okay, so now we go to let's save advent of code, advent. Okay, make a copy, and this is day 4. Day 4 input. Open it, delete it, go back here, copy it back to Emacs, paste. What? Did we copy it? Copy, paste. What? Yeah, paste. Okay, so anyway, so here is the good. Save it, close, open it, close, copy the file path, close, close, and back to the code. What? Close, back to the code. Now we just need to read this file path. Okay, read string, I believe. Yep, so x input equals to read string of this file. Okay, now run it. 2647. Okay, suppose this is answer for personal input. Are you sure? Yeah, I'm sure. Let's submit. That's not the right answer. Your answer is too high. Jesus. Ah, fuck. Still part of day 1. Fuck it. It's now 80 minutes almost. Yeah, 80 minutes. You know, people finish this in 2 minutes. Those fucking speed coders. God. What is this? Did we miss something? God. I'm not happy. I don't know what to do. I'm not happy. No, because then we're gonna two concurrent viewers. Okay, fantastic. Nobody's watching. You see, now we need to debug the code. You see, it's not apparent to me where we went wrong. That's the issue. Because then I need to debug the code. That just means like starting all over. And this is even just part 1. Did I miss something? Is there some like fast trick? Wait, did I get the input correct? The last thing you want is your input is wrong. Let's see, get your puzzle input, okay? Now, copy, new page, copy, 140. Should be right. Save it. Hey, we are not nobody. What? I forgot, what does that refer to? Oh, the people, the number of people watching. So the input, there is our input. Let's double check. Yeah, you got the input, right? This bunch of thing. Run the code. It says null. Okay, so remove that. Run the code. 2647. Shift tab A to show everything. You see, this is our process. 2647. Now, what the fuck? Now, is there some like implicit multiplication? Let's just be sure there's no implicit multiplication going on. What the? What? Two six four seven. Okay, I think the diagonal is wrong because they are equal. There's something fishy, okay? The diagonal is wrong. Transpose, you have to think about the diagonal, okay? Input is correct. Now we are in the debugging stage. Input should be 140 times 140, okay? So thank you. Yeah, 140, that's right. Yeah, 140 by 140. Did you finish the problem? Nine Barry. By the way, where are you from? Do I like? Are you Chinese? Because I was thinking maybe you are one of my friends I know. Okay, our input is correct. Yeah, fuck. I want to finish this, and it's only part 1. Fuck it. Oh, you don't want to transpose but mirroring. So let's think about this again. Yeah. Oh, you have to think. I don't want to think. Great tip, thanks. But okay, so let's see. Normally it's diagonal, so when it's diagonal, you take it that way. But so what happened when you transpose? Oh, that's right. Transposition doesn't change nothing, because transposition just flip it on the diagonal. It doesn't. That's why the answer is the same. That's why we got a logical error. That is our error. That is not, it's not a bug or something. It's our logic error. So we don't want transpose. To be honest, we haven't thought about it thoroughly. We are just like, oh, transpose will do it. Okay, so logical error. So you cannot do transpose because. So what you want is rotate, actually. Fantastic. So is there a rotate matrix thing in Wolfram language? I think so. This is the beauty of Wolfram language. You just search for question mark. How do you type question mark? Okay. Asterisk. Rotate. What you want is rotate matrix. Okay. Shift enter. Image rotate. Rotate left, rotate right, string rotate left. What does that mean? String rotate left. Okay, it just rotate represents a 2D graphics primitive. Okay, that's about graphics, which is fantastic. Wait, how is it different from transpose? That's right, transpose just what? I'm pretty sure there is a function for it, but something about matrix. Okay, now you got like tens of you got tens of functions about matrix. Let's think about this. Transpose fuck, you really, what you really want to do is actually just draw it without, because I was trying to avoid doing this because this is taking time. So if you have A, B, C, 1, 2, 3, so when you do a transpose, you got A, 1, 2, 3, A, B, C. Okay, now let's think about diagonal. Okay, so if you think about diagonal, so you got that, and here so if you think about diagonal, you see you got 1 A2 B3 C, same thing, 1 A2 B3 C. So transpose is not the right answer, but what you want is you want some kind of you mentioned flipped mirror. That's probably the answer. Oh, so if you want to do mirror, that's so trivial. You just reverse each matrix row. So yeah, so we don't have to think about this anymore. Like, you just reverse each row. Reverse the order of columns. Yeah, that will work. But you can easily reverse just by map, right? So yeah, let's get it to work. Okay, let's just. So we got condiagonal, then we got anti-diagonal, so it's not transpose. So so we just fix this line. So instead of transpose, we just map a function. What that function is gonna be? The function just reverse. Okay. Reverse. Let's say 1, 2, 3. That's right. So all you have to do is apply the reverse to each row. But you are probably right. There's a function, but but I not from. So I mean, I know this, so we can do this. Yep. So remove that. So now eval the whole thing. Wait. Comment that out. Wait. Let's put that eval the whole thing. Oh, what? Let's put this here. Eval the whole thing. 2633. Fantastic. Okay. So I think the new answer. This is the new answer. 2633. Oh God. Enter. That's the right answer. You are 1 gold star. Thank you. And thank you, Naiberry. So, okay, so now we are going to do part 2. Should I continue? It's 90 minutes. I want so let's do some cleanup, so you don't need that. Actually, remove that, actually. Let's just do some cleanup. Toy input is $18, and the personal input is, let's run it again. That's right. Yeah, okay. So now this is our code. Let's put it back, color it, show in browser. Okay, Scratchpad, then the real code. It's a bit long, but it can be shortened into one single line. Yes, and can be made a lot more efficient. But anyway, so part 2. Should I continue? I don't know. If it's easy, let's see. The elf looks quizzically at you. Did you understand the assignment? No. Fuck yourself. I just helped you. Looking for the instructions, you flipped over the word "eat" search to find that this isn't actually an Xmas puzzle. It's an X-mas puzzle, in which you are supposed to find 2 MAS in the shape of an X. Oh, Jesus. MAS. Okay, one way to achieve that is like this. Oh, Jesus. The nature of the puzzle changed. Fuck. Irrelevant characters have again been replaced with a dot in the above diagram. Within the X, each mass can be written forwards or backwards. Okay, so you need to find a cross. Here's the same example from before, but this time all of the X masses have been kept instead. Okay, so in this example, X mass appears 9 times. What the fuck? Wait, so it's not just horizontal. So if you have a horizontal or a diagonal or a vertical, it doesn't count. Okay, actually you can forget about horizontal and vertical. You only care about diagonals. You only care about diagonals. And also there's a condition. They must have the same center. That is, they share the letter A. That is forming a cross. So one cross counts as 1, not 2. So let's double check. That's 1. This is actually, is it easier if you show this? What kind of font are they using? Actually, it's easier in Emacs. So you got 1, 2, MAS, 3, 4, 5, 6, 7, 8. What? 9 times. Okay, actually 9. 1, 2, 3, 4, 5, 6, 7, 8. Okay, there's 1 here. So let's do it again. 1, 2, 3, 4, 5, 6, 7, 8, 9. 5, 6, 7, 8, 9. So, yeah, okay, so I understand the problem, but the algorithm is kind of entirely different. Okay, because this part 2, the approach will be entirely different. This is day 4. It's getting difficult already. What do you guys think? Yeah, so I think I shut down this video. Maybe we'll continue tonight. Tonight at 6 o'clock California time, which is 4 more hours. In 4.5 hours, we'll do the part 2. Okay, so let me think about this again. So yeah, you need to find the cross. So it is truly entirely different algorithm. So you have to think about that afresh. It would be nice to have some kind of pattern matching algorithm. Yeah, it's entirely different. Okay, that's it. So in summary, we did part 1, and here's a solution. And part 2 will be 6 o'clock p.m. California time. Okay, thank you guys for watching. That's it for today. If you have 20 minutes, good for you, fantastic, good work. Okay, so yeah, so bye guys. If you guys, you can join Xali Discord. You can find the invitation link on xali.info. Okay, bye guys.